Hello once again. So we're continuing with the workbook. We are now on chapter 6. I'm beginning with page 520, 6.1, equivalent rational expressions. A rational expression is an algebraic expression that can be written as the quotient of two polynomials. So examples of rational expressions that can be considered would be just like what was written in the book. I'm just copying it down. 2x plus 3 over 5x plus 4. All right. That is a rational expression according to the definition because it is the quotient of two polynomials. We talk about the quotient, it means you're dividing polynomial by another polynomial, or really it is a fraction. All right. You have a polynomial here, you have a polynomial here. All right. Now, these two qualify as polynomials. Now, what does not qualify as a polynomial is this one. This is not a polynomial. All right. Not a polynomial. Now, if you're thinking why, because the variable is an exponent. All right. What else is another example of one which is not a polynomial? All right. Another example would be x squared plus 4 over 2 root of x. Okay. Now, remember that you can rewrite this as x squared plus 4, 2x to the 1/2. Now, why is this not a polynomial? Because the exponent of x not a uh, is not a whole number, or no, not a whole number. It's not a positive number. Okay, so in pre-calc 12, it will be explained in detail what really is a polynomial. All right, when you get to polynomial functions. But for now, that is all you need to think about. Okay. So again, these two are not polynomials. Okay. Anything else that would be in this form would be a polynomial. Another example of a polynomial is this one, 6 over x. That's a polynomial. All right. Okay. We'll determine the non-permissible values for each rational expression. So a non-permissible value is defined as that value that would make the expression undefined. Now, if you will remember when we did radicals, all right, when we had something like this, square root of x, this one is going to have a domain which is greater than or equal to 0. All right, so I'll say it once again. The root of x will have a domain which is greater than or equal to 0, right? Because it is not defined when x is less than 0. The same idea, except that this time, instead of the x being inside a radical, it is a denominator. So really, the idea here is, okay, the denominator is x squared minus 9, make it equal to 0. All right, and those values that you will come up with would be the non-permissible values. Okay, that means that when you plug in a value that we will be able to solve for, and then those values will make the denominator 0. So two ways to do this. Either you do this, x squared equals 9, x is equal to plus or minus 3. Remember, when you get the square root, is plus or minus, okay? Oops. Or you can factor it out, which will be the same. All right, x plus 3 equals 0, x minus 3 equals 0, x equals 3, x equals, no, this one is negative 3, this one is positive 3. So same idea, all right? So the non-permissible values are 3, negative 3. Non-permissible values, 3, negative 3. All right. 3x plus 2 over x squared minus 8x plus 16. So again, make the denominator equal to 0. X squared minus 8x plus 16 is 0. Oh, wait a minute. This is a nice uh, trinomial. All right. I don't know if you noticed that. That is x minus 4 times x minus 4. Or that is just x minus 4 squared, isn't it? Right. Okay. I'm moving it up, that's why. Or x minus 4 is equal to 0, or x is equal to 4. Therefore, the non-permissible value is 4. Although in the book it says x equals 4. Well, I mean the same thing. What I'm saying is x cannot be equal to 4 because it will turn it into an undefined. Use multiplication and division to write two equivalent forms of this rational expression. This one is really easy because this one is no different from writing equivalent fractions. All right. With equivalent fractions, you can just multiply the top and the bottom by the same thing, and you will have um, an equivalent uh, expression. All right. The only difference here is that if you come up with something you multiply or divide by, and then it involves a variable, then it will have to have an additional um, uh, non-permissible value. Right now, the non-permissible value is x is not equal to 1, right? Because if you make x equals 1 here, that denominator becomes 0, all right? Now, some of you might think that, wait a minute, yeah, these two cancels out, yeah, but then you always look at the beginning, okay? All right. So one answer could be x plus 5 times x minus 1 over 2 times x minus 1. It said, all right, use multiplication. So let's multiply by, I don't know, as long as you multiply by the same thing, all right. Um, uh, x plus 3 over x plus 3, right? Because in the end, it cancels out, so you're not really changing the value of the expression. When you do that, another non-permissible value would be x is not equal to negative 3, right? Okay, so what else? If we are to divide the numerator and the denominator by the same, okay, yeah, we can do that, all right? X plus 5 times x minus 1 over 2 times x minus 1, okay? Now we're doing division, okay? We divide the top by x minus 1, we divide the bottom by x minus 1. What do you notice? These two will just cancel out, right? Uh, and the answer is x plus 5 over 2, okay? While the top will be different, but they're equivalent, okay? So there was no non-permissible value added because we just got rid of the x minus 1, okay? Next. So we are going to simplify expressions. So this one is another, um, it's similar to what you did in Math 10, so it will involve factoring, okay? Oh, I love factoring. So what can we cancel from the top with a? So negative 25 can be divided by 5, gives you a 7, no, a 5. Denominator gives you a 7, all right? What else? The a cubed cancels out with the a, leaves you with an a squared, right? B to the fifth cancels out with b squared, leaves you with b cubed, and then the c remains. Okay, so let's see what we have. So we have negative 5, all right, for the numerator, all right. There's a 7 in the denominator. The a still remains on top. The A in the bottom is gone. The B in the top is gone. The B on the bottom now has an exponent of 3. All right. What about the C? Well, the C remains on top. And there's your answer. Okay. What about B? So B, I think what we need to do here is to factor out a 3x from the top. All right. And that would give us 2x plus 4. All right. By doing this, you will notice that you can cancel out the 3x and the 3x here, and giving you a final answer of 2x plus 4. All right. Now, in the answer key, it says, okay, oh, by the way, sorry. The non-permissible values for the first one is A is not equal to 0. Okay. Now, if you're thinking, wait a minute, why is it that A cannot be equal to 0 when in the answer here, A is a numerator? Because you always have to go back to the original question. In the original, the denominator has an A, which cannot be a 0. All right. And B can also cannot be a 0 because obviously here there's a B. So really, whatever variables are in the denominator, they cannot make the denominator a 0. Now, in B, right from the beginning, x is not equal to 0 because of this, right? Now, kindly note that in the answer key, the 2 was factored out. I don't know why they did that. It didn't say that you have to factor that out. All right, so as far as I'm concerned, if this was a test question, you don't really need to factor that out anymore. Okay. Now, next one. X squared minus 49 over x squared minus 5x minus 14. So once again, we need to factor this out. The numerator is a perfect, now it's a difference of two squares. That would be x plus 7 times x minus 7. Well, then the denominator would be x minus 7, x plus 2. All right. Okay. So do you notice any common factor we can factor cancel? I think those two. So we have x plus 7 over x plus 2. Now what are the non-permissible values? X cannot be equal to what? Again, right from the beginning. So x cannot be equal to 2 and 7. Is that right? No, negative 2. Okay. So the last one, 2x squared minus 5x minus 3 over 9 minus x squared. So again, let's see how do we factor this out. I think this is going to be 2x and x. All right. This is plus 1 over 9 minus x squared. That's 3 minus x equals x because that's a difference of two squares. All right. Now, if you're thinking, wait a minute, can we cancel something out here? Well, you could. Some of you already see that these two sort of look the same. All right. Although some of you might want to take the extra step of doing this. 2x plus 1 times x minus 3 over, wait a minute, what if we factor a negative 1 from 3 minus x? So it becomes negative 1 times x minus 3. All right, we switch them around, times 3 plus x. Okay, all right. Now we can factor it out. We can cancel these two. And what is left? 2x plus 1 over negative 1 times 3 plus x. All right. I'm not sure if I agree with the answer. Maybe it's wrong. Okay, I'm just checking. 3 minus x because okay, 2x plus 1, x minus 3, that's 2x squared minus 5x minus 3, right? So that would have been 2x squared minus 5x minus 3. All right, 3 minus x, 3 plus x. Okay. Okay. So it seems that the answer key is wrong. Maybe they just forgot to put that. Anyway, the non-permissible value would be x cannot be equal to plus or minus 3. Now the final answer also may be like this. You can put the negative on top, or you can put it down. Oh, there is a negative, yeah. Or there is a negative right in front. I did not notice right away. And that's it. So I will just post the homework. And that's it for today, people. Until next time. Thanks for watching. Bye.